In this video, I am going to find the limit of a special function, which is e to the power x, as all of you know. So we are going to find the limit of this function as h approaches 0, f of x plus h minus f of x divided by h. But before I jump into the finding of limit, let me go ahead and define e to the power x. Let's say e to the power x. Actually, one definition of e to the power x is this. It's 1 plus x over 1 factorial plus x squared over 2 factorial plus x cubed over 3 factorial plus dot dot dot. This is just one definition. You may not have seen it, but if you have seen it, that's great. But I'm gonna go ahead and explain it to you regardless. So what is factorial? So let me give you an example. Let's say 3 factorial. 3 with an exclamation sign. In mathematics, it's read 3 factorial, which means that it's equal to 3 times 2 times 1 is equal to 6. Or 4 factorial is going to be 4 times 3 times 2 times 1 or 24. Or 5 factorial is going to be 5 times 4 times 3 times 2 times 1 is equal to 120, and so on. In general, n factorial is n is a positive integer, n times n minus 1, n minus 2, dot dot dot, 3 times 2 times 1. One special factorial that you may want to remember is called 0 factorial. We define it to be just 1. But we will not need this one here. But we will need this definition of exponential function or e to the power x. This is just one of the definitions, by the way. So let's go ahead and find this limit. That's my objective, right? So let's find f of x plus h. Given f of x is equal to e to the power x, f of x plus h is going to be e to the power x plus h. So I'm just going to go ahead and plug it in. Limit h approaches 0, f of x plus h, which is going to be e to the power x plus h, minus f of x is e to the power x, all of it divided by h. Now I'm going to take the limit h approaches 0. Now remember from your algebra class, a to the power x plus y is equal to a to the power x times a to the power y. So similarly, we can write e to the power x plus h is equal to e to the power x times e to the power h minus e to the power x. So these two guys is this. Now all of it divided by h. Now what I can do, I can go ahead and factor out e to the power x. So if I factor out e to the power x, I'm going to be left with e to the power h minus 1, all of it divided by h. Now at this point, I feel like I'm stuck. What can I do? I can't do anything else. I can plug in h equal to 0. I get e to the power 0 right here, right? But then e to the power 0 is going to be 1. 1 minus 1 is 0. And h approaches 0 is 0, right? So 0 over 0 situation. So we ran into a problem. How do we resolve this problem? This is how you do it. What you do is this. We use the definition of e to the power x. E to the power x is equal to 1 plus x over 1 factorial plus x squared over 2 factorial plus x cubed over 3 factorial. Now instead of x, I'm going to use h. So it's going to be 1 plus h over 1 factorial, h squared over 2 factorial, h cubed over 3 factorial, h to the power 4 over 4 factorial, and it keeps going. This is a series. Now I'm going to subtract 1 from both sides. That's going to give me this. And on the right hand side, I'm going to have h over 1 factorial, h squared over 2 factorial, h cubed over 3 factorial, and etc. Now from the right hand side, I'm going to factor out h. That's going to give me 1 plus h over 2 factorial, h squared over 3 factorial, h cubed over 4 factorial plus dot dot dot. It keeps going. Now I'm going to replace this. Look, this this is the same as this inside the parentheses. So I'm going to take this limit, which I do here, take this limit, and then replace e to the power h minus 1 by this expression. Now, if I do so, this h and this h are going to cancel each other out. I'm going to be left with e to the power x times 1, whatever is inside this parenthesis, right? Inside this parenthesis. So 1 plus h over 2 factorial, h square over 3 factorial, h cube over 4 factorial, and so on and so forth. This, and you know the properties of limits, you could sum it up, right? So you could write it as limit. You don't have to do it, but h approaches 0 e to the power x plus limit h approaches 0 h over 2 factorial plus limit h approaches 0 h over 3 h square over 3 factorial and plus dot dot dot. Now look, all of these terms, remaining terms, are going to become 0 because of the presence of h. Doesn't matter what is in the denominator, so long it's fixed, it's going to go to 0. Each of these terms are going to be 0, so the entire thing is 0. But limit h approaches 0 e to the power x must be just e to the power x, because there is no dependence of e to the power x to h, so that's what it is. So if you take the limit of this function, okay, limit h approaches 0 e to the power x plus h minus e to the power x over h, this thing is going to be nothing but e to the power x. And you just learned something new, which is called the derivative of e to the power x, which is just the function itself. This is the only function I can think of, that has the same as the derivative is the same as the original function. So derivative of e to the power x is e to the power x. Even though you may not know the derivatives yet, I'm just giving you a little heads up. I hope that this discussion was helpful. Thank you very much.